Ibrahim, all complex questions, what do you mean by that? All complex questions from where? Yeah, if you did all of them, and not just the assigned ones, yes, that should be good enough. But at the end, of course, you have to do recent yearly past papers as well. And then it should be fine, inshallah. Okay, can everyone let me know the questions you have? Bilal, you can also post the question that you could not do. Everyone, please let me know the questions you have from P3 trigonometry worksheet or any other questions on P3 trigonometry from any recent past paper that you want me to do. Because today is just going to be a practice session on trigonometry. I think we've got most of the people here now. So we are going to start. Let me open the worksheet. So we're saying we start with question number 1 first of all. Okay, so we'll start with question number 1 from the worksheet. Last part of this. Okay. $17, $20. All right. Okay, let's start with this one. This is question number 1 from the worksheet. Let's have a look at this. The first 2 parts are pretty standard parts, but we will do them anyway. Have we done those parts before? Let me just check. Okay, we did this example, but then we solved another equation, I think. That's 4. Okay, all right. Let's do question number 1. We'll do this full question because I think it's going to be a good review of some concepts. Okay, first part. It says express this thing in r sine of theta minus alpha form. Now, in such questions, the first thing that you have to see is this the standard form already or not? The first function is sine theta, and you have sine here. That means it is the standard form. This is minus, this is minus. So we can use the formulas directly. We can say this is A, and this is B. Right? A is equal to 4, and B is equal to 3. And just input values in the formula. R equals square root of A squared plus B squared. That would be 4 squared plus 3 squared. The value of R turns out to be 5. And then tan alpha equals B over A. That means 3 over 4. What's the value of alpha in degrees? Okay, so we've done the first part earlier, but it's okay. It just takes like 1 minute. What's the value of alpha that we get? 36.87 degrees. Okay, 36.87. Make sure to round off the second decimal correctly. You can lose 1 mark because of that. So if it's 3 marks, if it's 8.7 and you write 8.6, they can deduct 1 mark for that because they want the answer correct to 2 decimal places, right? Okay, now the second part says, hence solve this equation. Okay, now how do we solve this equation? It's 4 sine theta minus 3 cos theta equal to 2. That's the equation. We need to solve this for theta between 0 and 360. Theta is between 0 degrees and 360 degrees. Now, we have shown in the first part that this expression, the one on the left side, this can be written in r sine of theta minus alpha form such that r is 5 and alpha is 36.87. So we can write this equation in that form. We can say this is 5 sine of theta minus 36.87 equals 2. That's the equation that we have. Okay, and now we need to solve this equation. How do we solve this? we use a substitution. We say let A equals theta minus 36.87. Now, when that's the substitution that you're using, the equation will become 5 sine A equals 2, and then sine of A equals 0.4. Now, when you use the substitution, you also have to make sure that you adjust the interval accordingly. If you're solving equation in terms of A, the interval also has to be for A. Right now, it's for theta. So what is A going to be? Input 0 in place of theta. A is going to be between minus 36.87 because that's the value of A that we get when we input theta equal to 0 here. When we input theta equal to 360, we get 360 minus 36.87, which is 323.13. So A has to be between these two values. Now we find the basic angle. Sine alpha equals 0.4. What's the basic angle that we get from this? Sine inverse of 0.4 in degrees. 23.58 degrees, right? That's the basic angle. Now, which quadrants can we be in? It can be the first quadrant or the second quadrant. Why? Because sine is positive. Sine is positive in the first quadrant or in the second quadrant. So the basic angle can either be here or it can be here. So the first angle that we get is this. This is 23.58 degrees. And the second angle that we get is this. It's 180 minus 23.58 degrees. Okay, now let's put that substitution back. What was the substitution that we did? Theta minus 36.87. So we can say theta minus 36.87 equals 23.58, or theta minus 36.87 equals this thing, which is 156.42. You can see what the value of theta turns out to be. Plus 36.87. Okay, so one value that I'm getting is 60.4 degrees. And then the other is 193.3 degrees. Are these correct? Right? Okay, good. So these are the values of theta that we get. That's the second part. That's it. That's what we had to do in the second part. Why can't we take negative 23.58? It's within the range. We would take that if we were also using the fourth quadrant. We cannot be in the fourth quadrant because sine is positive here, right? Sine is positive only in the first and second quadrants. Fourth quadrant cannot be considered. If sine was negative and we could be in the fourth quadrant, then we would consider this as well. Okay. All right. Now let's look at part 3. It says write down the greatest possible value of this expression. Okay, now how do we think about this? 1 over 4 sine theta minus 3 cos theta plus 6. Remember paper 1 functions, trigonometric functions. How do we find range of trigonometric functions generally? We think of the sine and cos functions. Sine function, it is between minus 1 and 1. And similarly, cos function, that is also between minus 1 and 1. So sine and cos functions, they have their values between negative 1 and 1. The least values of these functions are negative 1. The greatest values are 1. We can use that here. But the problem is we have two different functions. We have sine and cos. We cannot find the range of a trigonometric function unless we have only one function there, because we can't input some value of both functions at the same time. For example, we can't say, let's input sine theta equal to 1 and cos theta equal to 1, because they are not equal to 1 at the same instant. Sine theta is 1 at some other point and cos theta is 1 at another point. So finding range is not possible if you do not have a single function. That is the reason there's this word hence here, that you have to use the first part somehow to answer this third part as well. Now, how is the first part relevant for this? We've got the same expression, 4 sine theta minus 3 cos theta in the denominator. We have written that in a different form earlier, and we can write this fraction as 1 over 5 sine of theta minus 36.87 plus 6. Okay, so that fraction is the same as this fraction. So we have already converted this part to one function earlier. Okay, so now we have this fraction. How do you find the greatest possible value of this fraction now? That's the question. How do you find the greatest possible value of this fraction? Extreme values of sine function are -1 and 1. When you have one complete cycle of the sine function or the cos function, the minimum value can be 1 and the maximum value can minimum value can be -1 and the maximum value can be 1. What that means is this thing here, sine of theta minus 36.87. Its maximum value can be 1 and its minimum value can be -1. So what we can do is we can once input sine equal to 1, and then we can input sine equal to -1. These are the extreme possible values of sine. They are going to give you the corresponding extreme values of this fraction as well. What are they going to be? If I input sine equal to 1, what that means is I would get 1 over 5 times 1 plus 6, which gives me 1 over 11. And if I input -1 in place of that, what do I get? I get 1 over 5 times -1 plus 6, which is 1 over 1, which is 1. One of these values is the least values of that fraction, and the other value is the greatest value of that fraction. You can see whichever is smaller value, you would say this is the smallest possible value. The bigger value is the greatest possible value of that fraction. So 1 is what we are looking for. The greatest value of this fraction is 1. Okay. If you remember paper 1, when you had to find range of functions like these, let's say you have 3 minus 2 sine x. You have 3 minus 2 sine x. And you had to find range of this function. You would say sine x is between -1 and +1, right? If you have one full cycle of sine, it's between -1 and +1. To find the extreme possible values, the maximum and minimum possible values of the function f, what you do is, in place of sine x, you once input -1. In this case, that gives you 5. In place of sine x, you input 1, and that gives you another value, which is 1. Whichever is the bigger value, that's the greatest possible value of that function. Whatever is the smaller value, that's the least possible value of that function. That's the same idea that we're using there. In the denominator, we have sine of theta minus 36.87. We are saying in place of that, let's input 1 once. In place of that, let's input -1, because those are the extreme values of sine, +1, -1, right? So we once input 1, then we input -1. The smaller value is the least possible value of this fraction, and the bigger value is the greatest possible value of this fraction. Okay, we were looking for the greatest possible value, that was 1. If they had asked for the least possible value, that would have been 1 over 11. Is that okay? Yes. Okay, great. So that was the last part. Let's look at the next one now. Okay, now we have 3, 17, 20, and another one that Bilal posted on WhatsApp. Okay, let's look at the worksheet questions first, and then we'll move on to the others as well. Question number 3, part 2. Okay. Let me look at the others as well. 17. Okay, so these are some good questions. Okay, let's start with 3, and then we'll do 17 and 20. You will keep the formula sheet in front of you when you're doing this. Let's do part 1. It says prove this identity. Okay, which side do we start from? The left hand side, because that has 4 theta. Have we done this before? Cos 4 theta plus 4 cos 2 theta. That was that. Okay, so that's the exact same question. Okay, so we have done the first part of this earlier, right? So you're asking about the second part. Okay, so what I'll do is I'll copy this there. The first part that we have already done. Right? We did this in the last session or on Tuesday. Yeah. This is actually question number 3. Okay, so first part we have already done before, so I've just copied that same working here. You're asking about the second part of this. Let's try that. Okay, so it says hence solve this equation. Now, how is it related to the first part? The left side is the same as this. We can write that as 8 cos raised to power 4 theta minus 3, the left side. So this equation can therefore be written as 8 cos raised to power 4 theta minus 3 equal to 2. That's the equation that we need to solve. Okay. 8 cos raised to power 4 theta minus 3 equals 2. And the interval is from 0 degrees to 360 degrees. How do we solve this equation now? It becomes cos raised to power 4 theta equals 5 over 8. Take fourth root on both sides, but remember, when we take fourth root, whenever we take an even root, square root, fourth root, sixth root, we always use plus minus, right? So we have plus minus fourth root of 5 over 8. You can see what that is. Fourth root of 5 over 8. That is 0.8891. Yeah, so you have to use plus minus, right? And now you find the basic angle. Cos alpha equals 0.8891. See what the basic angle turns out to be. That's 27.23 degrees. What that means is the basic angle is this, but since cos is plus minus, that means we have to consider all 4 possible quadrants, right? 1, 2, 3, 4. In all of those quadrants, you write the possible angles in the given interval that have this basic angle, right? We're using all quadrants because there's plus minus, right? So we start from this point and we find all the possible angles. The first angle is going to be 27.2 in the first quadrant. The second quadrant, 180 minus 27.23. That is 152.8 degrees. Then in the third quadrant, you have 180 plus 27.23. That would be 207.2 degrees. And then in the fourth quadrant, you have 360 minus 27.23. And that would be 332.8 degrees. Right? These are 4 possible answers that you get from this. The second part is fairly straightforward. That's all that you have to do. Yeah, don't forget plus minus whenever you're taking square root or fourth root or sixth root. With even roots, you always have plus minus. With odd roots like cube root, fifth root, you have the same sign as the original number. If it's a negative number, cube root is also going to be negative. If it's a positive number, the cube root is also going to be positive. Okay, so that was straightforward. Let's look at the next one now. Question number 3. The next was 17. Okay, let's try this now. Question number 17 from the worksheet. Okay. Question 17, let's look at the first part. It says express square root of x times cos theta plus square root of 10 times sine theta in this form, where r is positive and alpha is an acute angle. Give the value of alpha correct to 2 decimal places. Okay, so the first part is straightforward. Is it the standard form? Yes, because the first function is cos and you have to convert it to cos. You have plus here and you have minus here. It is already the standard form. You can just use the formulas directly. A is equal to square root of 6 and B is equal to square root of 10. Let's input values in the formula. R equals square root of A squared plus B squared. That means square root of 6 whole squared plus square root of 10 whole squared. 6 plus 10 is 16. Square root of that is 4. R equals 4. And then tan of alpha equals B over A. That means square root of 10 divided by square root of 6. What's tan inverse of this? Tan inverse of square root of 10 over 6. $52.24 degrees to 2 decimal places. You need to make sure that you round that off correctly. So that's 52.24 degrees. All right. That was part 1. Let's move on to the next one, part 2. It says, hence, in each of the following cases, find the smallest positive angle theta which satisfies this equation. How can we do this? Find the smallest positive angle theta which satisfies this equation. Okay. The equation is square root of 6 times cos theta plus square root of 10 times sine theta equals minus 4. Smallest positive angle theta. What does that mean? What's the interval for theta? Theta should be greater than 0, right? That's the interval for theta. It should be some positive number. And we're just looking for the smallest positive angle. So the first angle that we get, we just stop at that point. Okay. Now, how is it related to the first part? This is exactly the same expression that we had in the first part. So we can replace that with the form that we found there. Let me write that down. That was 4 cos of theta minus 52.24. So we can write this left-hand side as, this is exactly the same thing, right? Square root of 6. Yeah. We can write the left-hand side as 4 cos of theta minus 52.24 degrees equals minus 4. And then cos of theta minus 52.24 degrees equals minus 1. That's the equation that we need to solve. What do we do at this point? We can use a substitution. We can say let A equals theta minus 52.24. We have to adjust this interval accordingly as well. If this is greater than 0, what's the corresponding value for A when theta is 0? A should be greater than minus 52.24. Okay. Now, cos of A equals minus 1. When is cos negative? This is in degrees, right? Okay, yeah, degrees. When is cos negative 1? When is cos negative 1? If you remember the graph of cos, this is what it looks like. Cos is negative 1 at this point. This is 180 degrees. And before that, it's negative at minus 180. Right? What's the smallest value that we're getting? Is minus 180 in the interval? No, it's not. Is 180 in the interval? Yes. So the value of A that we're getting, the first value of A that we're getting is 180. The next would be 540 and so on. But 180 is the smallest value, so that's what we consider. What's the corresponding value of theta now? Theta minus 52.24 equals 180, and the value of theta is 232.2 degrees. Okay, that's part 2A. Okay. Now, in this case, you could actually do it without substitution as well. But since some of you might not be able to figure out when you can do it directly, I would say just always do it with substitution. And that will always work for you, even though it might take a few extra steps, but that's okay, as long as you can be sure that your answer is correct. Now, what about the next part? I think part B is where the problem might be, because that is slightly different from the other questions that you might have seen. It says square root of 6 times cos of half theta plus square root of 10 times sine of half theta equals 3. Now we need to solve this equation. Let's write that down here. Square root of 6 times cos of half theta plus square root of 10 times sine of half theta, that equals 3. That's the equation that we need to solve. Again, the interval for theta is that it has to be positive, but we're looking for the smallest positive value, right? All right, so theta is supposed to be some positive value. All right, how can we solve this now? Again, how is the previous part relevant? Let me write that down here as well. In the first part, what we have done is we have shown that under root 6 into cos of theta plus under root 10 into sine of theta, this can be written as 4 cos of theta minus 52.24 degrees. That is what we have done in the first part. We have shown that that expression can be written like this. Okay. Now, instead of theta, we've got half theta here. So when we convert this side of the equation to a form like this, in place of theta here, we're going to input half theta. So this becomes 4 cos of half theta minus 52.24 degrees. Everything else remains the same. The only difference is we had theta earlier. Now in place of that, we have half theta. So on the right side as well, where we had theta, we replace that with half theta. Make sense? Any problems until this point? Is this conversion okay with everyone? Okay, now how do we actually solve this equation? Again, we can use a substitution. We can say let A equals half theta minus 52.24. So whatever is inside here, we can substitute that with another letter. And now we have to substitute theta as well. Substitute the interval, adjust the interval as well. What's the corresponding value for A that we get? Let's input 0 in place of theta. We get A greater than minus 52.24. That's the interval for A that we have. Okay, now keep that in mind. This is important. You need to make sure that you're adjusting the interval as well. Okay, so the interval is adjusted. Now we say we have 4 cos of A. That equals 3. Cos A equals 3 over 4. Okay, find the basic angle. Cos alpha equals 3 over 4. What's the basic angle that we get? Cos inverse of 3 over 4, which is 0.75. That is 41.4 degrees. 41.41 degrees. That's the basic angle that we're getting. All right. Now we think of quadrants. Which quadrant can we be in? Cos is positive. That means it could either be the first quadrant or the fourth quadrant. So the basic angle could either be here or it could be here. Now, remember, we're looking for the smallest possible angle. Smallest possible angle. The interval for A is starting from minus 52.24. Now, yes, on the positive side here, we have this angle for A, that is 41.4. But this angle on the negative side also falls in this interval, right? So we are going to consider that, and we're going to say the smallest possible value of A that we're getting is negative 41.41 degrees. That is this angle here. That does fall in the interval, right? The interval starts from negative 52.24. So the smallest value of A that we're getting is this. That is what we use here. Now, we put the substitution back. What was the substitution? Half theta minus 52.24. That equals negative 41.41. Find the value of theta from this. You get half theta equal to 10.83, and then theta is equal to 21.7 degrees. That's the smallest possible value of theta that we have in this interval, such that theta is greater than 0. We will look for the smallest positive value of theta. And that's it, 21.7. If we had not adjusted this interval, we would wrongly assume that the first value that we're getting is this one for A, and that would give us another value of theta, which is also a solution. However, that's not the smallest possible solution. We were looking for the smallest possible value of theta. That would come from this negative value of A, which is only possible when you adjust the interval. Otherwise, you would not be able to find that. You would miss out on that value. Is that okay? Makes sense to everyone? So in problems like these, it's very important that you do adjust the interval like that. Okay, let's look at the next one. This was question number 17 from the worksheet. The next one you're saying is 20. Okay, question number 20 from the worksheet. Let's try this. It says, show that this equation can be written in this form. Tan of 60 plus theta plus tan of 60 minus theta, that equals k. So we have to use compound angle identities for tan, right? What are the compound angle identities for tan? One is, so we have both of them here, tan of A plus B and tan of A minus B. Let me write them here on the side. Tan of A plus B that is identical to tan of A plus tan of B divided by 1 minus tan of A times tan of B. And tan of A minus B, that is identical to tan A minus tan B divided by 1 plus tan A times tan B. Okay, they're written in the formula sheet. You can refer to that as well. That's what we can use to expand these expressions on the left side. So we have tan of 60 plus theta plus tan of 60 minus theta, that equals k. Let's just apply that identity and try to expand this and see what you get from that. 60 plus theta, we use the first identity for that, right? In place of A, we have 60. In place of B, we have theta. So it becomes tan of 60 plus tan of theta divided by 1 minus tan of 60 times tan of theta. And similarly, we expand the other one as well. This becomes tan 60 minus tan theta divided by 1 plus tan 60 times tan theta. On the other side, we have k. All right, now let's simplify this a bit. Tan 60, you can evaluate this on your calculator. it will give you square root of 3. Okay, tan 60, put that in a calculator, you get square root of 3. So you can simplify this as square root of 3 plus tan theta divided by 1 minus square root of 3 times tan theta plus square root of 3 minus tan theta divided by 1 plus square root of 3 times tan theta. This equals k. Okay, so we've done the expansion. Now let's look at what they want at the end. Make sure you have the end in mind. This is what you want at the end. Okay, so how do you go from this form to that form? You have 1 minus 3 tan square theta. We have tan square somewhere. So we have to multiply tan with each other to get tan square somehow. What we can do is we can take LCM here, right? Let's take LCM of these two fractions. What do we get in the denominator? 1 minus square root of 3 times tan theta times 1 plus square root of 3 tan theta, right? The denominators get multiplied. And if you notice, this is actually a minus b into a plus b form. We can do that in the next step. This gets multiplied here. So you have under root 3 plus tan theta times 1 plus under root 3 tan theta. Plus this gets multiplied by this, and that's under root 3 minus tan theta times 1 minus under root 3 tan theta. This equals k. Okay, again, keep the end in mind. That's what we want. Okay, let's simplify this now. Simplify the numerator and the denominator. In the numerator, under root 3 times 1, you get under root 3 plus under root 3 times under root 3. What's that? That's 3. Right? 3 raised to power 1 over 2 times 3 raised to power 1 over 2. That's 3 raised to power 1. So that becomes 3 tan theta plus tan theta into 1. That's tan theta plus under root tan theta into under root 3 tan theta. That is going to be under root 3 tan square theta. Okay, under root 3 times 1, that's under root 3. Under root 3 times this with a negative sign, that's minus 3 tan theta. And then minus tan theta plus under root 3 tan square theta. This whole thing is divided by this. This is a minus b into a plus b. So it can be written as a squared minus b squared. So that's 1 minus, or you can actually do it step by step. 1 squared minus under root 3 tan theta whole squared. On the other side, you have k. Okay, now let's simplify the numerator. A lot of things are getting cancelled out. 3 tan theta and minus 3 tan theta and minus tan theta. And then we have under root 3 plus under root 3. That becomes 2 under root 3. Under root 3 tan square theta plus under root 3 tan square theta. That becomes 2 under root 3 tan square theta. And in the denominator, you have 1 minus 3 tan square theta. That equals k. Again, look at what you want at the end. So we're almost there. So we can take this denominator to the other side now, so that we have this expression on the right side. And then in the numerator, we can take 2 under root 3 common. That will leave us with 1 plus tan square theta. So that's the last step now. Just take the denominator to the other side, and on the left side, you can take 2 square root of 3 common. That leaves you with 1 plus tan square theta in the on the left side. On the right side, you have k times 1 minus 3 tan square theta. And you have converted that equation to this form. This is what we wanted to do in the first part. Okay. So in trigonometry problems, a lot of times you would not be able to figure out in the beginning what the overall structure is going to be, but don't get scared by it. Just start doing something, and normally you will find a path along the way. Once you start doing it, you start getting ideas about what you can do. Just make sure you're always looking at what you want at the end. Keep the end in mind so that you can see if you're going in the right direction or not. That was the first part. Now it says, hence solve this this equation. Giving all solutions in this interval. Okay, hence means we have to use the previous part somehow. Now, how is it similar to the previous part? We have tan of 60 plus theta plus tan of 60 minus theta. We had the same thing here. On the other side, it was k earlier. Now it is 3 under root 3. That earlier equation, we converted to this form, right? The only thing that has changed now is in place of k, we have 3 under root 3. That's the only thing that has changed, right? So what we can do is we can say, okay, when we simplify this equation at the end, we should get the same form as before. Just in place of this k, we would have 3 under root 3, right? Because that's the only thing that's changing. So in this equation, we can just replace k with 3 under root 3 and then solve that equation. All right? For theta between 0 and 180. Let's do that. So we figured out that all we have to do is just replace k with 3 under root 3. So we have 2 under root 3 times 1 plus tan square theta. That equals 3 under root 3 times 1 minus 3 tan square theta. Okay, now let's simplify this. Under root 3 and under root 3, we can cancel them out, right? Because we can divide it on the other side. It'll get eliminated. And then the rest of it, we can simplify 2 plus 2 tan square theta. That equals 3 minus 9 tan square theta. And that gives us 11 tan square theta equal to 1. Tan square theta equal to 1 over 11. Take square root on both sides. Tan theta equals plus minus square root of 1 over 11. Theta, they said, is supposed to be from 0 to 180. Let's evaluate this. Plus minus 0.3015. Minimum 4 significant figures in your working. This is theta. Let's find the basic angle. Tan alpha equals 0.3015. The basic angle turns out to be tan inverse of this. That is 16.78 degrees. Okay, now which quadrants can we be in? It's plus minus. That means it can be any of the 4 quadrants. However, the interval is only up to 180. So we say the basic angle can either be here or it can be here. These are the 2 angles that we consider. The first angle that we get is in the first quadrant, which is 16.8 degrees. In the second quadrant, it would be 180 minus 16.78. And that turns out to be 163.2 degrees. These are the 2 values of theta that we get, and these are our final results. Make sense to everyone? Any other questions from the worksheet? We could do one more before we do that question that Bilal posted. Any other problems from the worksheet? Or maybe bring any other from a recent paper that we can do now. We've done enough from the worksheet. Okay, so let's look at this one now. November 19, question 4. Okay, let's do this next. After this now, question number 46, we'll have a look at that. But before that, let's do this question that you've posted here. Question 46, sorry, yeah. Question 46, we will have a look at that after this one. Okay, so this one, right? Question number 4 from this paper. And this is November 19. It does not look that difficult again. Okay, so we're saying the second part of this question, uh, first part is going to be required for the second part. What I'll do is I'll quickly find the values. This is in the standard form, right? The first term is sine and we're converting it to sine. So this is standard form. We can say a is equal to square root of 6, b is 1. What's r going to be? It's going to be square root of 6 whole squared plus 1 squared, which gives us square root of 7. And then tan of alpha, that is 1 over square root of 6. What's the value of alpha that you got? 22.2. You will lose 1 mark here. The question says, give your answer to 3 decimal places. What's the answer to 3 decimal places? 1 over square root of 6, tan inverse of that, decrease. It's 22.208. If you write anything other than this, even 207, you lose 1 mark. Okay, you have to round off the last decimal place. So it's 208. Okay, that's the value of alpha that we're getting in the first part. Okay, now it says, hence solve this equation. Now, how is this related to the first part? In the first part, what we've done is we have converted under root 6 sine of 2 theta, no, under root sine x plus cos x. We have converted this to under root 7 sine of x plus 22.208. So we've done this conversion in the first part. We've converted this to square root of 7 times sine of x plus 22.208. All right. Now, in the second part, they're saying, hence solve this equation, square root of sine 2 theta plus cos 2 theta, that is equal to 2. And the interval is from 0 degrees to 180 degrees. Now, again, do the same thing that we did in the previous question as well. You have x here, and you have x here on the right side. When this angle changes to 2 theta, it becomes square root of 7 times sine. In place of x here, you write 2 theta. That's the only change that you have. 2 theta plus 22.208. And that equals 2. That's the equation that you now need to solve. What do we do at this point? We can divide square root of 7 on the other side. Sine of 2 theta plus 22.208 equals 2 over square root of 7. Let's use a substitution. Let a equals 2 theta plus 22.208. And the equation would then become sine a equals 2 over square root of 7. Let's adjust the interval as well. If theta is 0, what's the value of a that we get? 22.208. If theta is 180, what do we get? 360 plus 22. That is 382.208. That's the interval that we've got for a. We will be looking for values of a within this interval. Let's find the basic angle. Sine alpha equals 2 over square root of 7. What's the basic angle? Sine inverse of 2 divided by square root of 7. That's 49.11 degrees. Which quadrants can we be in? Sine is positive. That means first and second quadrants. that's either here or here. The first angle that we get is this, and the second is this. They're both in the interval. So we can say A equals 49.11 in the first quadrant. In the second quadrant, 180 minus 49.11, and that should give you 130.89. Put that substitution back, 2 theta plus 22.208, 2 theta plus 22.208, that equals 49.11, or 2 theta plus 22.208. That equals this. You'll find the values of theta from this. You can see what they are. Okay, so the first value that I'm getting is 13.4 degrees. And then the second one is 54.3 degrees. These are the two values of theta that we're getting. Is that okay? What was the problem in this? Make sense now, right?
जी सर, वो बस 2 थीटा का नहीं पता था कि वो सब्स्टिट्यूट इसी तरह करना है. ओके.
Okay, all right. Let's do one more question from the worksheet. That is question number 24. Uske baad, I will see if I can find a difficult question from a recent paper, and then we end. So let's do two more questions. One this, and then I will look for a difficult question from a recent paper, and that will be it then. Let's do this quickly first. Question number 54 from the worksheet. No, 46. Okay, so it says angles A and B are such that sine of A plus 45 equals this, 4 secant square B plus 5 equals this. Without using a calculator, find the exact value of tan of A minus B. Okay, how do you find tan of A minus B? Tan of A minus B is going to be tan A minus tan B divided by 1 plus tan A times tan B, right? That's the identity for tan. So we need to find the values of tan A and tan B. Once we have them, all we have to do is input those values in this identity, and that's it. Now, how do you find tan A and tan B? That's the question. One equation that we have is sine of A plus 45 degrees. That equals 2 square root of 2 times cos of A. And another equation that we have is 4 secant square B plus 5. That equals 12 tan of B. Now, these are not simultaneous equations as such because this equation only has A and this equation only has B. So we can just solve them separately and find tan A and tan B from them. Okay. Let's start with the first one. This is a compound angle. This is a single angle. We would have to, first of all, expand this. Sine A plus sine 45. What does that become? Using the sine compound angle identity for sine, that is sine of A plus B. That's identical to sine A cos B plus cos A sine B. It's written in the formula sheet as well. Sine A cos 45 plus cos A sine 45. That equals 2 under root 2 cos A. Okay, that's what we get when we simplify that thing. Cos of 45, evaluate this on your calculator, that's under root 2 over 2. So under root 2 over 2 times sine of A plus sine of 45, that's also under root 2 over 2 times cos of A, that equals 2 under root 2 times cos of A. Make sense? Now we can simplify this because all the terms have square root of 2. All the terms are square root of 2. Since all the terms are square root of 2, we can just divide the whole thing by square root of 2. It will simplify the equation. It becomes 1 over 2 sine A plus 1 over 2 cos A plus 2 cos A. Make sense? What I've done is I've divided the whole equation by square root of 2 so that this term that's coming in every single term, this number that's coming in every single term, that gets cancelled. Now we have this. It becomes 1 over 2 sine A equal to 2 minus half. That will be 3 over 2 cos A. 2 and 2 also get cancelled. And we have sine A. If I bring cos A to the other side, sine A over cos A. That equals 3. And that's tan A. Tan A equals 3. That's the value of tan A that we have. Okay. Now we solve the other equation. How do we solve this? We have secant square and we have tan. We have to somehow convert secant square to something else so that we can solve this equation. Any idea? What identity should we use? What is secant square? Secant is reciprocal of 1 over of cos, but is that going to help if we write this as 1 over cos squared? Maybe not. Is there any identity that we can use here? Look at the formula sheet. You have this identity 1 plus tan square theta, that is secant square theta. So you can convert secant square to tan squared, yes. So this becomes 4 into 1 plus tan square b plus 5. So we can replace this with 1 plus tan squared. It's there in the formula sheet. That was one of the first few identities that we did in paper 3. This one, 1 plus tan squared is secant square theta. Okay, now let's simplify this further. This equals 12 tan b. Now 4 plus 4 tan squared b plus 5 equals 12 tan b. Let's bring all terms to one side. 4 tan squared b minus 12 tan b plus 9 equals 0. Right? Now we need to solve this quadratic equation. We can use a substitution for this if we want. You can say, for instance, let t be tan b. So we can say this becomes 4t squared minus 12t plus 9 equal to 0. Can we factorize this? 36 by adding them. 8 times 4 is now 6. So we can use 6 and 6. 4t squared minus 6t plus 9 equals 0. We get two factors from this, 2t minus 3 and 2t minus 3. Okay, so this is actually a square. It's a perfect square, this thing, 2t minus 3 whole squared. So we get only one value of t, which is 3 over 2 from this. So tan of b therefore is 3 over 2. All right. So we found tan A and tan B. Now we just put it there in that equation. Tan of A minus B, that is supposed to be tan A minus tan B divided by 1 plus tan A times tan B. All right. Now you simplify this, 3 minus 3 over 2 divided by 1 plus 3 times 3 over 2. And that should give you the result. You can see what that is. In the numerator, 3 minus 1.5, that's just 1.5. In the denominator, 1 plus 9 over 2, that is 4.5. 3 over 11, that's the value that we're getting for tan of A minus B. And that's what we were looking for. Is that all right? Not that difficult for 8 marks. That's a lot of marks in paper 3. Did not really require anything very complicated. This should not take that much time. 8 minutes, I would say, for these 8 marks, because this was not that difficult. There was not much that you had to think about. Generally, the ratio is 1.5 minutes for every mark. So That would make it 12 minutes, but that's just the average. This was an easier question, I would say. So I would say spend just 8 minutes on this and maybe spend those extra 4 minutes on some more difficult question, which you will have to think more. Okay, now let's go back. Not backwards. Let me find another question that we can do. And then we end for today. So I'll look for one from some recent paper, which somebody might have asked me earlier. P3 trigonometry, no. Okay, P3 trigonometry. Okay, this we've already done. This is not that complicated. Okay, I've actually seen some more difficult questions in some recent papers. Let me see if I can find one of them quickly from this other topic that I have. Questions recent. Wait, just give me a minute. I'm just looking for one question that we can do. 72. Okay, I've seen some more difficult questions in these recent papers, but I'm just not able to find them right now. Yearly past papers. Where are they? Yeah, this is the kind that I was talking about. This is from March 24. One last question and then we end with this, okay? March 24, paper 3-2. Question number 8. All right, last question for today. Let's do this quickly. This is March 24, paper 3-2, question number 8. Express 3 sine x plus 2 under root 2 cos of x plus pi over 4 in the form r sine of x plus alpha, where r is greater than 0 and alpha is between 0 and pi over 2. State the exact value of r and give alpha correct to 3 decimal places. Now, the problem in this is the first function is sine, yes, and you're converting it to sine, but this is still not the standard form because this is cos of x plus pi over 4. It's not just cos x, it's cos of x plus pi over 4, right? What do we do with this? Before converting it to this form, we would need to expand this, right? Before we can use the formulas, we would have to expand this thing, all right? How do we expand this? We use the compound angle identity for cos of A plus B. That is going to be cos of A cos B minus sine of A sine B, right? Let's use that to expand it. 3 sine x plus 2 under root 2 times cos x into cos of pi over 4 minus sine x into sine of pi over 4. Right? Now let's simplify this. 3 sine x plus 2 under root 2 times cos of pi over 4. Put that in a calculator. That should give you square root of 2 over 2. And then you have cos x with that. Sine of pi over 4, that's sine of 45 degrees. That's also going to be under root 2 over 2 times sine x. Let's simplify this. 3 sine x plus 2 under root 2 gets multiplied with this. 2 and 2 get cancelled. Under root 2 into under root 2, that will be 2. So you have 2 cos x. And similarly there you have minus 2 sine x. And that simplifies to 3 minus 2, that's 1 sine x plus 2 cos of x. So that's what you have to do first. Once you have simplified it to this form, now you can use those formulas to convert it to r sine of x plus alpha. All right. How do you do that now? What's the value of A? A is 1 and B is 2. Now we use those formulas. R equals square root of A squared plus B squared, which gives us square root of 1 squared plus 2 squared. R equals square root of 5. And then tan of alpha equals B over A, which is 2 over 1. Alpha equals tan inverse of 2. Keep in mind that alpha is supposed to be in radians. Okay, so make sure your calculator is in radian mode for this. Angle unit, radian. Tan inverse of 2. So that's 1.107. It says 3 decimal places. So you have 1.107. That's the value of alpha that we get. So what's that form going to be? It's square root of 5 times sine of x plus 1.107. This is what we get when we convert it to this form. Okay, that's the first part. Slightly different from the usual questions that you get like this. You could not use the formula directly. You first had to convert it to, you first had to simplify this and then use the formula. Okay, second part. It says, hence solve this equation for theta between minus 4 pi and plus 4 pi. How do you solve this equation now? How do we think about this? What have we done in the first part? Let's write that down here so we have that in front. 3 sine x plus 2 under root 2 into cos of x plus pi over 4. This was the original expression that we had there. We wrote that in the form square root of 5 into sine of x plus 1.107. This is what we've done in the first part. We had this expression, we wrote that in this form. Okay. Now they want us to solve this equation somehow. Now let's compare what is it that has changed in this form. Compare the angle first of all. We had x plus pi over 4 here. Now we have half theta plus pi over 4. And here as well we have half theta. So what has changed is in place of x now, you have half theta. That's the one thing that has changed. So on the right side as well, in place of x here, you would have half theta. Okay. But the numbers are also not the same. This is 6, this is 4. Here we had 3 and 2. So the whole thing has also multiplied by 2, right? So instead of 3, you've got 6. Instead of 2 under root 2, you have 4 under root 2. So that means if you were to multiply this expression by 2 on the left side, you would also have to multiply by 2 on the right side. So the expression on the right would actually be 2 under root 5 times sine of x plus pi over 4 now. So you have to multiply by 2 here. And in that form as well, you would have this 2 multiplied. So that means this equation therefore can now be written as 2 square root of 5 times sine, in place of x we put half theta, plus 1.107. This equals 3. So this thing we write like this, and then on the right side we have 3. Now we can solve this equation. Is this conversion fine to everyone? Any problems with this? Because that's the tricky part here. Any questions on this? All right, good. So now that we have this form, the question says theta is between minus 4 pi and plus 4 pi, right? Theta is between minus 4 pi and plus 4 pi. How do we solve this now? We use a substitution. We can say let this thing be something else. So let's say let a equals half theta plus 1.107. So that the equation becomes 2 under root 5 into sine of a equals 3. Now we also have to adjust the interval accordingly. What's the interval for a going to be? We input minus 4 pi here and see what that gives us. In place of theta, you input minus 4 pi, right? So you have minus 4 pi divided by 2 plus 1.107. So the lower limit for a therefore is minus 5.176. Okay, what about the upper limit? Input plus 4 pi in place of theta. And that gives us 7.390. So the interval for a now is between these two values. Okay, that's the interval for a. What do we do next now? Find the basic angle. So we can first make sine a the subject. Sine a equals 3 over 2 under root 5. It's a positive value, right? Let's find the basic angle. Sine alpha equals 3 over 2 under root 5. The basic angle, what does that turn out to be? Make sure your calculator is in radian mode. Sine inverse of 3 over 2 square root of 5. Okay, so that's given me 0.7353. Minimum 4 significant figures when you're working. Now you think of quadrants. Which quadrants can we be in? Sine is positive. Sine positive means we can either be in the first quadrant or the second quadrant. These are the only two quadrants that are possible. So the angle alpha can either be here or it can be here. Now we start measuring the angle from the positive x-axis. This is the first angle that we're getting. So we can say A equals 0.7353. That's the first value of A. Let's go further. This is the second value that we're getting. A equals pi minus 0.7353. That will be another value. We'll come back to that. This is also in the interval, right? But now we need to think what other value, what other possible values can we have? What's the maximum limit here? 7.39. Is that greater than 2 pi or less than 2 pi? This is greater than 2 pi. 2 pi is 6.28, right? This is greater than 2 pi. So it is possible that we can complete one full circle and come back to an angle after that. So we can go one full circle and come back here to this point again. And that might fall in the interval still. So we have to check that. Let's check that. If we do one full circle, 2 pi, and then come back to that point again, like this, That's going to be 2 pi plus 0.7353. Let's check if that is in the interval. 2 pi plus 0.7353. That's 7.01. That's less than this. That does fall in the interval. So we do have to consider this as well. Okay. So this has to be considered as well. That's another possible value of A that we're getting. Let me just write that here as well. This is 7.0185. Okay. But now we are very close to the upper limit. If we were to go any further than this, to this point, this will be outside the interval. You can check that as well. That will go outside the interval. So on the positive side, we don't have any other possible answers. All right. But if we look at the interval again, the interval is also going in the negative direction, right? It's also going in the negative direction. You also have to go clockwise and see if there's any possible angle inside the interval in the clockwise direction. Let's check that. So if you go clockwise, this is the first angle that we find there. Is that in the interval? Let's figure that out. This is pi plus the basic angle, which is 0.7353. But since we're going clockwise, we put a negative sign with that. Let's see what this number is.
Minus 3.876.
Minus 3.876. Thank you. So that's the number that we get. This is also in the interval. Okay, so we also have to consider this. Then we can go further. We can check if this is in the interval or not. What about that?
It starts going above 7.
No, it's in the negative direction. Negative direction. Minus 2 pi plus 0.7353. That's minus 5.54. Is that in the interval or not?
No.
That's not, right? That's outside the interval, so we do not consider that. So these are the 4 possible values of A that we're getting, that we have written down here. Now we put that substitution back. So that was a lot of work, right? For these marks, 7353, that's 2.4066. Now we put that substitution back, half theta plus 1.107. So we have half theta plus 1.107 equal to this. Half theta plus 1.107 equal to this. Half theta plus 1.107 equal to this. And half theta plus 1.107 equal to this. So if all of that is not enough, now we also need to find the values of theta from each one of these 4 equations and see what they turn out to be. Has anyone done this? The values of theta, what do you get? .7353 minus 1.107 times 2. Okay, so the first value that I'm getting is minus 0.743. Okay, then the next one, you make structure like this and then just change the angle there, 2.4066. That's giving me 2.599, so that's 2.60. And then the next one, that is 7.0185. That's 11.8. And then finally, minus 3.876. That's given
minus 9.966.
Minus 9.97. These are the 4 possible values of theta that we're getting. These are our solutions. All right. This was one of the more difficult ones in the recent past papers. I hope that makes sense. That's it on trigonometry. For Monday, I expect you to have attempted a lot of questions from differentiation worksheet, basically everything apart from implicit differentiation. Please make sure to do that, because that is what is really going to help understand things better. If you're not practicing, I'm warning you again and again, you might just forget everything. Okay, so that's very common in A levels, that you understand something and then you don't practice it for like 8-10 days, and then you start forgetting whatever you've learned and you start panicking. The only way to avoid that is right away after you learn something, start practicing. In that way, you'll be able to retain what you've learned. Okay, so I'll see you again on Monday, inshallah, when we complete differentiation and do some practice questions on that. Allah Hafiz. Shoot. Why is that posted there?